All right, welcome to grade 6. This is Eureka Math Squared, Module 3, Lesson 3. I think I said that out of order. I think I wanted to say Eureka Math Squared first, and then grade 6, Module 3, Lesson 3. So let's assume I did that. All right, so this is introducing rational numbers in the world of opposites. Okay, the previous lesson we dealt with opposites with integers. And now we're just tossing rational numbers in there. So all about rational numbers. Now integers, sure, the integers were the whole numbers, right? So that was your -5 or your +5 or your 0. Notice no fractional values there at all. All those guys, those are your integers. Your rational numbers include all of those integers and all fractional values. All fractional values. Positive, negative, doesn't matter. Basically, what I like to say is if you can plot it on a number line, then it's a rational number. It can be placed on a number line. Now, what can't be put on a number line? Well, those are your values like you're repeating a decimal. So you're like your 4.3 repeating, that kind of thing. That would be, your rational type thing. You can't find it. But the fractional value, you can. So decimal fraction. So if I did 4 1/3, then I can find that. But some of these decimals that just go on and on and on forever, and they're not defined. So if they're not defined, well, then you just can't put it on a number line. If you can't put it on a number line, then of course it wouldn't be a rational number. Okay, so that's the deal with that guy. All right, so noticing all these values, they're rational here because they can be placed and you see them on a number line, right? They can be plotted. And so those are rational numbers: positive, negative, 0. Whole numbers, all rational numbers. Okay, so here we go. What number is the opposite of the number that point A represents? Okay, so point A is, let's see what's going on here. So we have a 0 over here, right? So we have to figure out the interval. In other words, the space between each of these little marks, right? So what's the distance between each of these hash marks? Let's see what's going on here. Okay, so I have 4 whole, right here, right? So there's 4. Here's what I'm gonna do. I'm gonna try to split these guys in half, right? So if this is a 4 and this is a 0, right smack in the middle should be 2 somewhere, right? So let's see what's going on here. Point 2, maybe that's 2. That's got to be 2 right there. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so there's 2. And if I split those in half, hopefully I can find out where 3 is, right? So I'm trying to find this interval here. If this is a 0.8 and this is a 0, this is probably a 0.4, right? So 0.8. So it looks like we're increasing by 0.4. That should be a 1.2. Okay, that would mean this is a 2 point. If I added 4 to that, would be an 8. Okay, so let's see. If I add 0.4 to that, there's my 3.2, then a 3.6. Yeah, so we're looking like a 0.4 interval, right? The distance between each. Okay, that would mean this guy over here is a negative 0.4. There's your negative 0.8. If I, let's see, if I count another 0.4 down from negative 0.8, that would be my negative 1.2. There's my negative 1.6. This should then be a negative 2 or negative 2.0, right? So if I add a 0.4, or technically subtract a 0.4, right? So that should be a negative 0.8, and subtract another one, and that should be a negative 3.6. Okay, so yeah, so it's looking like all my interval is a 0.4 interval, and I think it actually asks me that. If it does, terrific. If it doesn't, well, I'm going to use it anyway. So what number is the opposite that's plotted for point A? Well, point A is 0.4. right? So 0.4. So what I'm looking for is the opposite. When I deal with the opposite, every time I hear that opposite, what I'm going to do is multiply by a -1. And I do that by showing a parenthesis and putting in a negative. Now, if I put that 1 in there, that's fine. That means -1 times zero point 0.4. And how I run that is I take the two factors, I take the 1 and the zero point 0.4, and I multiply them together, and I get zero point 0.4, right? Because anything times 1 is itself. So zero point 0.4 times 1 is zero point 0.4. And then I have a negative times a positive, and that always gives me a negative. Okay. Now, normally I don't write the 1. It's understood that if you just have that negative outside that parenthesis, this guy right here, it's understood that you're multiplying by a -1. Okay, so here's my answer, but they want to show it on the number line, right? So I'm doing the same distance from 0 on the other side of 0. Okay, so if I'm 0.4 going this way, then I'm negative 0.4 going that way. Okay, and they want me to plot it, so I'm going to put a dot, right, and label that point D. So I'm going to put a D right next to that. Okay, so there you have it. Maybe I'll put an equal sign as well, just to show it's what it belongs, and that's the value at the same time. Okay, so that's what we're doing here. We're just plotting and dealing with opposites. There is one more thing I want to talk about. We'll get to that in a second. Let's do a couple more here. So the number is the opposite of the number that point B represents. Well, point B is over here. I kind of messed up this number line. It's all over the place. Well, if this is point B is a negative 1.6, then I want that positive 1.6. So I'm going to put that dot right in there. I'm going to plot that out, and they want a point E. There you go. All right, so that's a positive equal. Let's put that a positive 1.6, right? So now I just want to show you what that looks like dealing with the opposite. So if I have that negative 1.6, right, and I want the opposite of that, I'm going to do the same thing I did over here. I'm going to wrap that up. As soon as I hear I want the opposite of something, I wrap it up and I multiply it by -1, just like that. Okay. Now again, that 1 is really there, even though I don't write it. So if you want to use it for a little while, that's fine. 1 times my 1.6 gives me 1.6, right? Anything times 1 is itself, and then a negative times a negative, that gives me a positive. But I don't have to write that positive symbol, so I can just write my 1.6 like that. Okay? It's good practice for you. Here we go. So let's do the next one. The number is the opposite of the opposite. Okay, now here's when things get interesting, right? So that first opposite, or any opposite, I wrap it up, I multiply by -1. And here's another opposite, so I'm going to wrap that up and multiply it by -1 again. Okay, so point C is hanging out over here, right? There's point C, and I want the opposite of the opposite. Well, the opposite of the opposite brings me right back where I was, right? It's just common sense. So my answer is going to be a 3.2. That I'm certain of. But I want to show how to deal with that with the opposite of the opposite. So here's my 3.2. Always start with your value. And just like before, I'm going to wrap that up, multiply it by -1. Oh, that's a bad parenthesis. There we go. Wrap that up, multiply that by -1, but I want the opposite of the opposite. So I have to use two of these things. Now, I don't like to use another parenthesis that's the same exact size. To me, it looks a little bit confusing. What I like to do is wrap this thing up with a different set of parentheses, one that's clearly different from the first one, and I'll multiply that, but I'll put a negative sign, or I'll multiply that by -1. So technically I have a -1 there, and I have another -1 in there. So I'm doing that twice, right? So let's multiply the inside. We always will multiply from the inside out when working with parentheses. So this 1 times 3.2 gives me 3.2. A negative times a positive gives me a negative. Okay, so I'm done with everything inside here. So now I'm going to downgrade this parenthesis. I don't want to use that big old parenthesis anymore. I have no need for that. So I'm going to turn it into a regular size parenthesis, but I didn't multiply this -1 yet. So I'm going to put him over out there. And now I'm going to connect, right? He could be a -1, right? You can put that in if you want, put that in there. So my 1 times 3.2 is 3.2. And then my negative times my negative gives me my positive. So there it is. There's my 3.2. I knew that all along. but that's showing how it works mathematically. Okay. And now what do they want here? They want points A, E, and C represented as decimal fractions. Oh, okay. So let me stack these up. Here's A, here's E, here's C. Let's see what's going on with A. A is 0.4, so I'll put my 0.4 in there. E, point E is that 1.6, so I'll put that in there. And point C is 3.2. All right, so this is a review skill here. I'm just turning these things, let's see, as decimal fractions. That's fine. So fractionally, this is just read as 0.4 or 4/10. So I just do what it says, 4/10. Now I can simplify that, right? I can divide both these values by 2, and I get 2/5. Okay, he's done. All right. This guy, 1.6. Well, that's 1 and 6/10. Okay, all I'm doing is reading it, right? That's my 6/10 right there. So that can be simplified as well. 1 and then I can divide both of these by 2. So I get a 3/5. Okay, that's that guy. And so what else do I have here? One more. Oh, if I want to keep it as a fraction, if they don't want mixed numbers, now I can just multiply and add, and I wind up with 8/5. So maybe they want that. I'm not sure. They want decimal fractions. Maybe they don't want the mixed number. If they don't want the mixed number, I'll keep it as an improper fraction then. But I wrote both just in case. 3 and, here's this last one, right? 2/10. So 2/10. Again, simplify 3 and 1/5, right? Because that's divide by 2, divide by 2. And again, if they want that improper fraction, I can multiply and add. So 5 times 3 is 15 plus 1, 16/5, right? So that takes care of that. So there are your decimal fractions. A little bit of a review on dealing with that, but that's okay. Okay, so what are the opposites of the decimal fractions from part D? The so I want the opposites of that. Oh, okay. Let's see. From part D, the opposites. Okay, so let's see. If I'm doing that A, all of them, they want all of these, huh? Decimal fractions from part D, all these guys. Okay, so the opposite of, right, so the opposite of 2/5, right, would be -2/5. Okay, right. What's the next one? Part E. The opposite of 8/5. I'm going to wrap that up, multiply by -1. Okay, and I get a -8/5. Okay, and part C. I think they wanted that one, right? Yep. C, 16/5. I'm just going to keep them as improper. Wrap that up, multiply by -1, and I wind up with a -16/5. Okay. All right, looking pretty good here. Let's see what else we have. All right, so, oh, okay, so let's do some plotting. Let's have some fun in here. Oh, they're giving me a blank number line here, except for the 0. So we might have to do a little bit of thinking here. Oh, and there's this consecutive integer I want to talk about as well. So let's plot. Looks like we don't have to go beyond 3 whole, right? So I'm just converting these guys super quick. I know this is going to be a -2 1/3. So what I want to do is have enough space when I plan this out, right? I don't want to put a 1 over here, right, and a -1 over here, because some of these values are going to go beyond that 1 or -1. So I just want to make sure I cover everything. So I'm going to put a 3 out here and a -3 out here. I don't think any value goes beyond a 3 or a -3. Okay, so then I'm just going to put more hash marks in for my whole numbers. Always good to do a little bit of planning before you commit to putting values in, and then you realize you made a mistake and what a mess. Okay, so let's see. Plot points at 2/3 and the opposites. Well, if I want thirds, right, thirds, let me zoom in here. That's between a 0 and a 1, right? So I'm just going to put in a couple of smaller hash marks to show thirds, right? Here's 1/3, here's 2/3. All right, let me zoom out again. And I'm going to plot that 2/3 right there. But they want the opposite. So the opposite is going to be the same distance from 0 on the other side of 0. So that's this guy. And when they want plot, that means put a dot there. There you go. All right, so they're there. They're there. They are where they need to be. I think so anyway. Now they want a -5/3. Well, a -5/3 is going to be a -1 and 2/3. So I'm going to make more thirds out of this. Okay. And so a negative 1 and 2/3 is going to be over here, right? Because this is my -1 and 1/3, and this is my -1 and 2/3. There it is. So they want the opposite. So that's over here. And so this is going to be a +1 and 2/3 because this is a +1 and 1/3. So I'm going to plot that right there. So that's good. All right. So they want the opposite of that, right? So the opposite of that negative is going to be that +5/3. Okay. Fill in the blank rational number. -7/3, and I already converted that, is located between what consecutive integers? Now, consecutive integers means in a row, okay, without skipping anything, right? One after the other. So if I have a -7/3, that's a -2 and 1/3. That's going to hang out in here somewhere. And all I want are the integers on either side. Okay, so that would be a -3 and a -2. That's where that point would land, in between those two consecutive, right? One after the other integers. Okay, so what are they asking here? Each interval on the number line has an equal length of, oh, the interval. Well, it looks like I'm making these intervals pretty close together, right? And between every little hash mark is 1/3. So that would be then my answer. Okay, so that's the deal with that. And I'm pretty sure that's all I wanted to do with you guys today. Okay, so that should get you through the lesson and you should be good to go. All right, so thanks so much. Hope you enjoyed that. Take care. Bye bye.